Okie doke. Welcome, everybody. Before I get started with the solar news here, does anybody have any specific questions they wanted to raise? Yeah, Bob, you've got something?
Well, first of all, guess what Florida's governor did with the solar bill?
Yeah, that's in my news. He took out the big veto pen. Guess who's running for president? So that's, yep. So that's good. Yeah, I'll give a little details on that.
And second, that Enphase purchased Solargraph as a tool, which I've been getting educated in. But more important is the #1 distributor of panels in the United States is CED Green Tech. And I just quoted some jobs over there, and they are purchased also by Enphase. And guess whose products are available? Even the 8s are available there, which is so hard to get, and they just came out in March. But I can't find anybody else's there. So just beware that Enphase is, I think it's for Enphase. I could be wrong on that.
Yeah, I think we're seeing, well, Enphase certainly has been having a run of success recently, but we're seeing a lot of vertical integration, I think, in the marketplace. So it won't surprise me to see more of that, where manufacturers are buying up software systems, or distributors are partially owned or wholly owned by manufacturers. You know, we'll see how that all plays out. We still see quite a lot of suppliers in the solar panel arena, but the inverter arena seems to be shrinking, you know, to just a handful of dominant players there. And eventually we'll only be able to buy one battery charger, and that'll be from our car charger. That'll be from Tony's company. So, you know, that will be the market dominant player. Okay, and I'll wait a little bit because Gabriel had sent me through a question. I'll address that if he comes on a little bit later. But in the meantime, let me go ahead and hit the solar news. And if you think of anything as we're going through, after I finish, I'll give you guys an opportunity there. There's interesting, we've talked in the past about photovoltaics, you know, panels that float on water. And the largest photovoltaic system in the country is being installed in New Jersey, of all places. It's an 8.9 megawatt floating solar array. It's going to be on a reservoir, 16,510 panels, and it will be used to power the America Water Canoe Brook Water Treatment Plant. So they're using the reservoir that's there for the water treatment to be a facility for their solar. The advantages, of course, with the photovoltaics is they do help solve some of the water evaporation issues. They reduce that. They reduce algae buildup, and obviously by reducing sunlight that hits the water, and they keep the panels cooler. I've never seen any specific cost studies on photovoltaics, but I have to assume it's a expensive process compared to ground mounted systems or even rooftop systems. I don't have anything to back that up except my assumption that putting things on water is going to be a little more expensive. Energy Sage just came out with their 9th annual installer survey. And some of the takeaways from that survey were they survey installers, and they found that about 60% of them say that they've been hurt by supply chain issues, having trouble getting product as well as selling product. Half of them said that if the Congress extends the investment tax credit for 10 years, they'll add staff. And if they eliminate it, they'll reduce staff. So take that for what it is. That's their perception at the moment. I don't know of any specific plans at the moment for Congress to extend it by 10 years. I looked around for something because that seemed like a weird thing to ask them, you know, unless somebody's making noise about doing it for 10 years. but I fully expect the investment tax credit to be extended in some form or fashion. We don't know how that'll be.
They currently can't even extend the regular tax stuff at the moment.
Yeah,
They're completely locked up. So there's no indication of any special bill that I've seen. I kind of follow that, but
it'll probably get, attached to some sort of military spending bill or,
Ukrainian bill.
a congressional pay raise, that'll go through.
Yeah.
So, yeah, we'll see how that works out. But I think it's due to expire at the end of 2023, if I remember right, or does it phase down?
I think
once?
it phases down, doesn't it?
Yeah, and then maybe it goes it's at 26% right now. I think it goes through 26% next year. Then maybe it reduces to 22% in 2024 and then goes to 0. I think that's how it works. So that makes sense because that would push it to beyond the election. And then probably in December of 2024, they'll rush through something and that will help everybody's planning. The most requested battery, I found this interesting in the report. When customers request a battery backup system for their array, 47% of them request Tesla. When installers install battery bank systems, only 29% install Tesla and 51% install Enphase. So Enphase is the largest residential battery backup. Generac is number 2 with 32%, and Tesla is number 3. And that tracks with what I've heard from installers who are doing it, is they just can't get the product, they can't get the support. It's, it's good in theory, but in practice, it tends to be difficult. So they go with somebody who will answer their telephone calls. That's kind of it. The biggest barrier to growing business shifted this year. Last year, the biggest barrier companies said to growing their business was they needed more customers. That makes sense. This year, the biggest barrier is lack of trained labor. 44% say they don't have people to install the systems that they've got orders for. I saw a cute article that Falling Water, the place by Frank Lloyd Wright there in Western Pennsylvania, with the water going underneath the home, is now fully solar. So they've installed solar, not on the building, but in a ground mounted system in a field next to it. If you've never been there, you should go to Falling Water. It's a very interesting place to go to. I found it the most uncomfortable home I've ever been in. I can't imagine a human being living in it, but it's beautiful, But if you like doorways that are like 30 or 26 inches wide, and if you like rooms that are small and damp moisture coming up through the floor, I guess.
But Jay, you live in a house made out of rubber tires.
I know. Who am I one? I'm one to say, but no, I found Falling Water was all about the outside visual and nothing about the inside comfort, which I couldn't imagine living there. Okay, California just passed a bill, AB 2316, requires that 51% of all its community solar projects benefit low-income households. They also required that these systems be paired with storage to help with grid resiliency and reliability. So that's where California is heading. As Bob just mentioned, Governor Ron DeSantis vetoed House Bill 741, which would have gutted Florida's net metering program. Right now, Florida has a pretty good net metering program. It will pay you full retail for your production, up to system sizes up to 2 megawatts for a residential, which is pretty amazing. I couldn't see when you overproduced, what they paid you. They mentioned in one article offset, but I didn't know if that just meant, they'll pay you for whatever the wholesale rate of of generation would be. But then the other thing that this bill would have done, it would have phased that out. And then it also would have said that they can charge you whatever they want to charge you as a grid access fee if you have solar. To give you a sense of what that might be, Arizona just tried to pass a law charging $100 a month grid access fees for people who have solar. So that's where they're coming from right now. I know my electric co-op charges me $40 a month, which seems relatively excessive. But if I didn't have solar, they'd only charge me $20. So I guess I can get rid of my solar panels.
So what did Arizona's situation? They tried and it failed, or it's just in the works?
I think they failed. That was what the articles seemed to indicate. CEA was taking credit for killing the bill. So whether it rears its ugly head again, I don't know. Nevada, if I remember, tried to do something like that before. There's always such a pushback. You know, they try and sneak it in, but today's market, there's so many people with solar, you know, I think they can't really kind of sneak these things through.
Do you think the fix is in?
Well, you know, it's always in. Question is, how long does it stay fixed, you know? But it's hard to know. It's going to be state by state. Some states, the utilities are pretty powerful. Other states, they seem to be less so. And Ron DeSantis mentioned that 9,000 people in the state of Florida work for the PV industry. So the PV industry is becoming a political force unto itself. And, you know, so that may be something that will counteract the utilities' heavy-handed lobbying that has taken place in the past.
So Jay, are you saying that this was a bad solar bill that Santos vetoed, so he's helping the solar program?
Yes,
Okay.
yes, for sure. Yeah,
We have that recorded, Don. We
Yeah,
have
yeah.
that recorded.
I just
for
wanted
all
you
of
to say that
history.
out loud, Jay.
yeah, Ron DeSantis is my new best friend, right? But because it's Florida, we're not allowed to talk about it. So you can have solar, but you can't mention it to anybody who's less than 12 years old. Okay?
Or at an
Okay.
amusement park.
All right, so in the first 2 months of 2000 and or whatever year this is, 2022, 96.3% of all new electric generation in the United States was from renewable, which is pretty astounding. The other 4% or so was from natural gas. So there has been no coal, no nuclear forever. I mean, those two industries are in phase out mode. They're not in growth mode. And according to FERC, currently renewables account for 26.3% of all of the generating capacity on the grid. So that's pretty significant. Solar grew 36% in the 2 months of this year versus the 2 months the year preceding. So even with all the supply chain constraints, it's been at least a good first 2 months. Now, whether that's going to balance out over the year, who knows?
Jay, do you ever get any worldwide data similar to this? I'm just curious because with all the Ukraine and the Russian stuff, I've been hearing that a lot of the Europeans are, they've turned all their nuclear power plants back up to full. They're started digging more coal again and things like that in Germany.
I think this would be new installations, so something like that wouldn't have affected it.
Okay.
All the data I've ever seen before is the U.S. has been kind of similar to most nations for a while. Germany was a leader in this for a while. Spain was a leader. Then China has been a leader. China's kind of an all of the above kind of thing. They've been putting in coal, gas, renewables, but I think my estimation, just based on the simple economics, is if I were someone in Europe, I would be looking towards wind and solar as much as possible to deal with the supply chain issues that, of course, the Russian supply has brought to the forefront, but
I would agree, but they're not exactly in the best. Germany, if you've ever been there, is not the sunniest place in the world, no matter how many panels they put in.
sure, but we found that amount of sunshine is a minor consideration with solar, as opposed to the cost of electricity, which is much more of an issue. And what was I going to say? Anyway, I lost my thought there. Okay, so speaking of China, in the last 10 years, China's market share of polysilicon production has grown from 30% of the world's market to 80% of the world's market. So it's interesting that polysilicon is used to make semiconductors and solar cells. So what the tariffs have addressed have been modules. So that does not affect polysilicon production. So I guess if you're wanting to figure out what the next zombie apocalypse is going to be, essentially China controls the polysilicon marketplace for the world. So they basically control the production of modules and the production of semiconductors, which is, it's a good thing we don't need either of those. So that's a.
Well, can't we steal their technology?
Yep, I'm sure we could. Can we steal their supply of polysilicon? Okay, so that's all the news that I had. I was seeing, I don't see Gabriel on here. Yeah, Bill? Bill, you've got a question? I don't hear you there, Bill. Yeah.
Yeah, Jay, I'm on. This is Gabe.
Oh, okay, Gabe. All right, Bill can figure out his mic. Yeah, Gabe, you had sent me a question through about a project that you were potentially working on. Do you want to recap the issue there?
Sure. It's someone who wants, so it's New Mexico. They say they have net metering, but their co-op really doesn't. They pay 19 cents a kilowatt hour, and anything they sell, they get 2 cents a kilowatt hour. So they would like to just be independent. I'm telling them they should stay connected to the grid. They get charged $20 a month, or I'm sorry, $30 a month to be connected. But regardless, suggesting they stay connected. They want to depend on their solar, but also have solar as a backup in case the grid goes down. And they consume about 1,000 kilowatt hours a month, except for December through February, they consume twice that. And what I was wondering is, instead of, I'm looking at an AC or DC coupled system, and instead of having a separate panel for critical loads, I was wondering if you can get a smart panel and just have the critical loads be a software solution rather than a hardware configuration. And so that was my first question. The other thing I've run into is I've been shopping for panels for them, and I've looked at Silfab, Hanwha, REC, and Panasonic, and only one of them shows a hail rating on it, and it shows it as the speed at which a 1-inch ball hit the panel before it broke. I was surprised I wasn't finding hail ratings on the other ones, and just wondering what's going on there.
Yeah, I'm surprised that it may be that they just simply didn't list it. I thought all of those would have had hail ratings. I forget what the UL standard is for hail, but if I remember right, a rating of 4 is the best there is. And that's like a 2-inch ball dropping from 25 feet or whatever twice in the same spot.
Right. It may be that they're listing the UL rating and just assuming that you understand that it qualifies for that, because of that. So I'll dig into it deeper, but, and maybe I just didn't look in the right place or didn't find, but I looked all through their spec sheets and couldn't find hail ratings. So.
Yeah, it's in the textbook. It's in the Understanding Photovoltaics book. So You can,
I definitely remember it there. That's why I was looking for it.
right. Yeah, as far as your first question, I would say I was doing a little thinking about this and looking actually at some of these monitoring systems, either a smart service panel, or you can get them where you can just attach CTs to specific breakers, circuits, and control them that way. Of course, you're going to need to have some sort of disconnecting transfer switch for the system to go in island mode when the grid goes down. So normally the way that works is it disconnects your main and then goes to a sub panel. And then the sub panel is fed off of the array and the batteries. Now you could disconnect the entire system from the grid, and then instead of connecting from the inverter to the sub panel, you connect from the inverter to the main panel, so that you're shutting off your entire system. And then you could control loads, either manually by going in and flipping breakers, or you can do it through specific load control software on your phone. The only thing that I could see as an issue there that occurred to me is, when the grid goes down, you may be having a lot of loads running, which would overpower your backup, your inverter, unless it's been sized adequately to run everything. So if you're not fast enough, you might squeal your inverter and kick it off until you start disconnecting loads. And that would especially be the case. It sounds like they've got electric heat. So in the wintertime, when the heaters are running, the sun's not really shining, the grid goes down, that's going to overpower their inverter, I would assume.
Yeah, no, I think that's right. I'm trying to also talk them out of, they do have electric space heaters, and I'm trying to talk them out of those. They obviously also have propane, and so trying to get them to convert some of their electric to propane, but we'll see. You're right, that would be a risk.
Yeah, geothermal, of course, is a good one. I don't know if there are any of these monitoring systems that would automatically disconnect in case the grid goes down, where you could set it up that all those circuits would turn off as soon as it loses sight of the grid, to avoid that, and then allow you to turn them back on individually. So
well, it seems like at least at a minimum, they're selling and buying that. So the monitoring system would have to be enough to allow you to sell and buy at any given time. Isn't that right?
Well, it tells you they do that just through the meter. You mean as far as tracking, how much you're sending back to the grid, how much you're drawing from the grid?
Exactly. Yeah.
Yeah, that's all done through the meter itself, the utility meter. What these CTs do, these current transformers that go onto the wires, is they monitor amp flow through the wires and then allow you to determine, what's going on going to each circuit.
Yeah.
And they also have systems where you can simply plug into a plug, and it takes it all the way down to a load level. So you could plug in, a fan or a heater or something into a specific outlet. So.
I know this is a question about solar, but I wonder if, Gabriel, if you've looked into it all, why they're consuming 1,000 kilowatt hours a month in the non-winter time. I just wonder about their water heater, and switching to a heat pump water heater these days is a pretty cheap switch compared to the amount of electricity that you start consuming with that.
Yeah. I asked him about any other electric appliances, and it sounds like it's really just the space heaters in the summer. It's a ranch, and so they have a lot of pumps and things like that. I think that they're running. But one other just curiosity point, I talked to the co-op that they're a part of about, what their requirements are, et cetera. And the co-op said that they would, in any new installation, they would change the custody meter, but they would also require the co-op to put a meter on their production, on their solar production, so that they can monitor how much they're producing. And, I didn't get into an argument with the co-op, but it sounded a bit invasive, but I guess they have the right to do that. But
Yeah.
anyway, so they put in 2 meters.
Well, co-ops are, I wonder why they would, because typically your inverter is going to monitor your production.
Well, I asked him that. I said, well, if we put in equipment that does that electronically, do you still need to put in your own meter? And they said, yeah, because we need it to communicate with our office and let us know how much solar they're producing. And so I thought it was bizarre.
If it's not going to the grid, why do they care?
That's right. That's the point. Yeah.
Yeah.
I thought it was kind of invasive, but they feel like they need to know that information. So
If they're only getting 2 cents a kilowatt hour net metered, why don't they stop net metering and start working like Don's got with that Solarc in a direction where they're just they're just working on their side of the meter.
right.
Well, that's what they're trying to get to with
exactly.
basically self-consumption as much as possible. But I guess I would agree with you, Gabriel, that I would stay connected to the grid, because we don't know what kind of services are going to be coming from the grid at some point. If you're only paying 20 or 30 bucks a month, seems to me a worthwhile backup.
Yeah, I agree.
Yeah.
What I'm getting ready to do at my place is I'm putting a Solarc in, and I'm all going to be behind their meter, and I'm not going to net meter, and I'm still going to be connected to the grid, and I'm still going to have the CTs on there, and it'll island. It'll anti-island, it'll do everything, and the electric company won't even need to know that I'm doing anything.
Right.
I mean, I've got permitting.
Yeah, I think probably what that co-op is doing is usually co-ops are exempted from any of the net metering laws. And they're making that rule just because they can.
Right.
It's I agree with you that it sounds invasive for, it may be just as innocent as we want to accumulate statistics, but
Right.
but then, I mean, why would they insist upon it?
Yep.
You typically wouldn't pay for having a meter. I mean, it costs them some money to put in a meter and stuff just for statistics. That seems, most of the co-op guys I know aren't that into statistics.
Well, a lot of times what they were doing, at least in the early days, is when they would come and install a bi-directional meter, they could take their monodirectional meter and flip it over as a production meter, because the production from your array is only one way. At least it's supposed to be. So they could just, they'd often give it to the homeowner. Here, you want this? You can use it, because no good to us anymore. So. All right. Well, anybody else have anything before we jump into, Bill, have you solved your microphone?
I don't know.
Yeah,
Do
I can hear you.
anything?
I can hear you
great.
now.
Can I share my desktop?
Sure.
I run across this new gravity storage, something like this where they raise and lower a huge weight.
Yeah.
Is being prototyped in many locations, not in the United States, but elsewhere. And I was very intrigued by it. It competes with pump storage. It competes with lithium, grid storage via lithium. And I find it, as a mechanical engineer, I find it very interesting and challenging. And not only that, this is an IEEE article, by the way. If you want me to share the link, I can do so. It just, lithium is a chemical process, right? This is a purely mechanical process, except for the silicon involved in converting the torque through a generator to grid compliant power. But you know, this article does suggest, and I have no reason not to believe it, that tower right there has an equivalent kWh stored as the lithium battery that's in Australia, with a obviously very much smaller footprint. And anyway, I'll copy and paste this link to the article into the chat part, if I can do that.
Yeah, I've seen those before where basically they're stacking up basically concrete blocks when they have excess energy, and then they lower those blocks to the ground, and the tension that's created as they lower them generates power. And
Yeah.
I always think of them as giant Jenga towers, you know, where they're pulling all that stuff out of there. So
as a chemical engineer, I would argue that chemical storage systems have fewer losses than mechanical storage systems, right? But there is a train, I think it's in Arizona or Utah, that is it's an electric train, and basically they fill it up with weights, and when they have extra power, they run it up a mountain. And when they need power, they let it roll down the mountain, and recover the electricity. So that's the only mechanical storage system that I know of, at least a couple of years ago.
yeah, we went to a place in Wales called the Center for Alternative Technology, and they had a really cool incline rail that took you up to the top of this old slate mine where they had their facility. And what they did is, because there was a little stream that rolled down the side of the mountain, the incline train was counterbalanced, and they would fill up a tank with water, and then that would pull the car up to the top of the mountain, and then they would release the water down below, and then the train would lower down, and I thought that was quite a cool little system.
Well, you could fill the train with water at the top of the hill where the water fills, dump it at the bottom, and you'd avoid all of the expense of turbines and
Right, no,
piping if you had a railroad in place.
Yeah, that's what they did. They filled it at the top, locked the system in place, and then when they wanted to move it, they just unlocked it, let the weight take it down, released it, and then it counterbalanced. Or they could have just dumped it in on all the passengers, everybody get a nice shower or something. So, all right, well, let me jump into the issue that, yeah, Bill?
I wanted to share one other thing, the subject of smart. Has anyone heard of the new breaker panel labeled SPAN? It's
Yes,
a very
sir.
smart breaker panel, and I was really impressed with what they offer. I don't know, apparently somebody else knows something about it. I'll stop sharing, and I put the link to this also in the chat. Does somebody else have some info about it?
All I know is it was on this old house, on one of their constructions, they put that in.
Yeah, it sounds like what they're doing, and we're getting a lot, we're moving in this direction. You can take some sort of smart device and deal with it at the load level, at an individual plug, at the circuit level, or at the entire breaker level as well, the whole panel. And I guess it's just going to be a matter of economics as to which one makes the most sense. But obviously, if you're going to rewire your whole, replace your panel, then you've got some expense there from an electrician coming in and doing it. Those CT, the current transformers are pretty easy to install. Although technically you probably need an electrician to do it. But I don't know. I think we're going to see a lot of that stuff coming into play where it becomes the norm, where you can remotely control all of your devices, turning things on and off. It's going to be interesting. Okay, well, Bob had raised an issue last week. He's working on a project, and he was trying to do, it's a relatively complex roof. Let's see if I can find the image here. Well, let me jump into PV watts first. So the issue had to do with how can you use PV watts and derating to determine just how much the system is going to be producing. And I think I'll try and find that here in a second, but let me walk through some of the things with PV watts. Because if you have a location, and I think most of you guys are familiar with using PV watts, if not, this will be particularly helpful. But let's say you're looking at a system and it's going to be an 8 kW system. Well, I'll back up one screen. The first thing you want to do is put in a location. So I just typed in Athens. I meant Athens, Ohio, but we got Athens, Greece here. So so Athens, Greece is as good as any. So let's jump in, and I'm going to put in an 8 kW system, standard modules. You can pick standard, premium, or thin film. What's the array type? Is it fixed, roof mounted? So let's just say it's a roof mounted system, but it could be single axis tracking, dual axis tracking. And then where Bob was getting into is a little bit about what is the appropriate systems loss. So how would we figure that out, which we'll get to in a second. But then we also get into the tilt of the roof, which is the angle, and then the azimuth or the orientation. 180 degrees being true solar south, 90 degrees would be solar east, and so on and so forth. So you plug those numbers. So let's say that it's a 26 degree pitch and it's facing 170 degrees here, azimuth. So then we go and it will tell us what our system production is going to be. And this will say that given what we've just typed in, it's going to produce 11,271 kilowatt hours per year. And here's the breakdown.
Funny where you were.
Lynn, I think you've got your mic on. There you go. Okay, so this is the basics. So this will tell you what you're going to be producing. But then there are a couple other things that you often don't get into. And they're down here under the advanced parameters. And then we have system losses that we have to figure out. So remember last week, we talked a little bit about clipping and the AC to DC or the inverter load ratio. And here's where you can plug in your inverter load ratio. And before I explain the inverter load ratio, let me just show you some of what the effect is. So with an inverter load ratio or a DC to AC size ratio of 1.3, it's producing 11,271. So if we were to do a 1-for-1, where the size of the array is the size of the inverter, so I set this at 100%, it actually produces, what was the other one? 271, was it? So it's pretty close, but actually a little bit less than if I had a 1.1 or 1.2 here. If I put 1.2, which is how it comes set, it's producing a little bit more, not enough to really be overly dramatic about. Let's say I went to a 2, I had twice as big an array as my inverter. Well, now it's going to be significantly less, about 10% less. So like everything else, there's a little bit of a sweet spot here in the inverter load ratio, and it tends to be about 1.2 to 1.3. So what do I mean? What do I mean by the inverter load ratio? Well, let me do a quick little drawing about clipping. So what we talk about when you would think that if I have a 10 kW array, or I'll just say 8 kW, because this is the size we're dealing with, that I would need an 8 kW inverter. And that would be a 1 inverter load ratio. But the reality is typically we get like an 8 kW array and a, say a 6 kW inverter. So that would be 8 divided by 6, and that ends up being, is my math right if I say 1.33? It's a third.
Yep.
Yep. So that's my inverter load ratio. So that's the difference. And what I worry about, or have worried about in the past, is, okay, let's say I put a 6 kW inverter on my system and I've got an 8 kW array, and I'm trying to figure out about how much production this system is going to produce. Well, how does that affect things? And what we've just seen from PV Watts is we type in the DC system size, the size of the array. And in this case, I would be typing in a 1.33 inverter ratio. And by putting that in, it's now calculated how much having that smaller inverter is going to affect it. So putting in a 6 kW inverter is not going to affect it very much differently than if I put in an 8 kW inverter. And why is that the case? It's because of this concept of clipping, where, let me clear that out of there, is, let's say that I've got, we'll do it with a microinverter, just one thing. And let's say that this is a 290 watt microinverter, and I've got a 290 watt panel. And during the day, this is going to be my production curve, be a little smoother than that. If I was on an STC day, a day of 1,000 watt per square meter and 25 degrees Celsius. Now, if I were to put a bigger panel in, then let's say I put a 350 watt panel, then the curve is going to look something like this. So this might be my 350. Well, this amount of power gets clipped off, but all of this power is additional power that's being added to my system by having the bigger array. And that's why it doesn't affect it adversely by having a smaller inverter. This is the inverter here, as compared to the array size. So hopefully that makes sense. Plus, to consider that most days of the year, you never get to standard test conditions anyway. So your inverter is going to be producing somewhere below that, or the panel is going to produce somewhere below that cutoff curve regardless. So a clipping ratio of 1.2, 1.3 is pretty standard in the industry, and PV Watts is designed to factor that in. The other thing that was in this diagram with PV Watts that you may or may not be aware of is ground cover ratio. And ground cover ratio down here is how much of the surface is covered by solar panels. And it really doesn't affect a traditional rooftop mounted system in a residential setting, because those are usually a flat plane. So your ground cover ratio is going to be 100%. There's no inter-row shading issues, things like that, but if you had a ballasted roof mounted system and you had to shift these panels apart from each other to avoid inter-row shading, then you'd have a less than 100% ground cover ratio. Not quite sure why they put that in there though, because I don't see where that affects outcome. all it would affect is how big a space you need for your solar panels. But I plugged in some different numbers and it didn't seem to make any difference in the production. So why they have that in there, not quite sure. But yeah, Bill?
In the past, as recently as a week ago, there was a third column at PV watts, namely the value of the energy produced. And I note that that's gone, and you had to put in an advanced parameter, namely what you pay for what dollar per kilowatt hour, and that was used to compute the value of the solar energy harness. Why did they make that go away? That's new. That's just happened.
Yeah, because that would always be here down under advanced. You're right. My guess is it was probably due to pressure from some of these design programs. Most of them integrate in with PV watts. And so I know you were mentioning, Bob, like, is it Solargraph, the one you're using? And PV Sketch and there's dozens and dozens. They integrate in with PV watts to get all of the analysis there. And they maintain databases of pricing from utilities. And so you plug in who's your utility and what plan you're under, and it sets in and integrates all of the pricing data. Could be that the pricing data has gotten so complex with time of day usage and variable plans that number was just not very functional anymore. The idea of dealing with a fixed number for most of your designs. I usually ignored it. So yeah, Bob.
When we had that last discussion, personally, you said that there was an area that one of the factors was double counted.
Yeah.
It was.
Yeah, I'm going to get to that. Let's.
Okay, before you move on to that, I think I understand how that ground cover works. PV Watts has an option where you can give it an area and it calculates what size of an array will fit in that area.
Oh, okay.
And so I think if you use that option and you use a ground cover area of less than one or greater than one, it would have to be less than one. But anyway, it will use that value to calculate a smaller array that you could fit in that area. I think that's how that works.
Okay, that makes sense. Because it really does focus on area.
Yeah, you have that option where you can draw out the space that you have for panels, and it calculates how many panels it can fit into that area.
In PV Watts, it does that. I know in a lot of the design programs, you could do that.
Yeah, if you go back to that page that you have, that you were showing earlier in PV Watts.
Sure. Here we go.
That little box.
Draw
to the
your
right,
system.
Right there. Yeah,
there you
exactly. Go. If you give it a specific address, it'll show the roof of that address.
Oh, okay.
And you draw out how much space you have. And even for a ground mounted system, for example, if you did it in a field, it would use that number you just gave it to adjust how big a system you could fit in that area.
Okay, well, that makes sense. Yeah, that's good. I never even noticed that. I mean, I don't know that it's going to be as functional as some of the other design programs, but it's there and it's free. So
yep.
May as well use it. Let me share the picture of the system that Bob was working on and some of the issues that you're going to run into. You can see this is the roof format of the system that he was looking at. And the orientation here, this is going to be facing southwest a little bit, section C of the roof. Section F is going here. And he had the system generate a shading report for this using, I assume, LiDAR through the system, light radar kind of thing. But these two numbers that they're giving, This is where Bob was getting into the fact that some of these issues are kind of twice. Because he was running into, we have section A here, which is kind of a meaningless section. So let's go with F. 88%. So essentially it's saying that 12% of the solar resource is shaded on that roof section. Section C, 21% of the solar resource is going to be shaded. So that is going to be the amount of shading that we would plug into our derate factor. But then they also give you a total solar resource fraction. And what that means is if this house were perfectly oriented, so if it were oriented to solar south, the angle was perfect, and there was no shading, that gives you your total solar resource. Well, taking into account the fact that it's not perfectly oriented and it's not at a perfect angle and it has shading, what is the total amount of what we could have gotten? What are we going to get? So section F is saying, all right, 79%. Section C is saying 77%. And what I was explaining to Bob is that when you put in the angle and the orientation in PV watts, you're already taking into account the orientation portion of this number. It's going to adjust for that. So all you have to add to your derate is the shading factor. And because he was looking at putting panels on both F and C, we sort of took a place in between. So 21% shading here, 12% shading here. And I think we figured, what was it, about 18% or 15%, somewhere in there.
15%.
15% for shading. So that then leads us to what are some of the other things that we have to factor in our derate. And so the derating can get into a number of factors, shade being one of them. Shade is right here. So in the shading number, if we took the average, we would say 15% or 0.85 would be our number here. So what is the model power tolerance? So the model power tolerance is essentially says, when you buy a panel, it's going to be plus or minus 5% of whatever it was rated for. You know, if you get one that's made on a Monday, it might produce 5% less power. Say it's a 300 watt panel and it's only producing 285 watts on a good day. And then you get one that's produced on a Wednesday and it's producing 315 watts. So they're saying in the specs from the panel, we're saying this is a 300 watt panel plus or minus 5% or plus or minus 3%. Well, when you hook up to a string inverter, plus or minus basically means minus. You know, it's going to operate at whatever the lowest common denominator is. But when you have module level power electronics that are managing each panel at the panel level, all of that's going to even itself out, because the one that's operating at plus 5% is going to produce 5% more. The one that's producing less than 5% or 5% less is going to produce 5% less. But when they're all aggregated together, you should end up at what it was rated for. So with microinverters or any module level power electronic that is used at the module level, I would tend to just simply discount this as a derate factor. If I'm doing a string inverter for a ground mounted system, yeah, I might have to plug that in and I'd have to get that number from the panel specifications. The inverter is just, I mean, how much is your inverter loss? You'll get that from the inverter specs. If you are incorporating a transformer as well, let's say you have to step it down from 480 three-phase to 208 three-phase, there may be some losses in that process, or step it up. Module mismatch, once again, this is a string thing. So when these things are interacting together in a string, if one panel is shaded or one panel is misbehaving for some for whatever reason, it's going to affect the other panels in that string. But if we're dealing with them at the module level, I think you can discount that one as well. Now, there will be some losses due to diodes and connections in the systems. So they're saying about 0.5% for diodes and all your connections. They're also giving us for voltage drop and the like, 2% for DC wiring, 1% for your AC wiring. So they're factoring in 3% in there. I usually throw in 2%, 3% is generous. Most of the time, this is a little bit of a theoretical exercise because you're just kind of saying, what do I think my production is going to be? But as Bob's running into in Illinois, the whole REC grant issue is based that your production has to match what you estimate. So there it becomes real numbers. If you don't meet your production numbers that you forecast, then they begin to impose fines and they want their money back. So that becomes a big issue, which tends to lead you to be a bit more conservative. Soiling is another issue, and I actually did some research on this prior to this, which usually I just talk off the top of my head. But there are a number of things that can cause soiling on a panel. We can think of normally as dust. I've seen it with pollen. You know, if there are trees around, a lot of oak trees will spit out a lot of pollen. That can accumulate. Pollution in an urban environment could be a factor that sticks to these panels. And there was a study done in 2001, found that the average amount of power loss for solar due to dust or soiling is between 1.5% and 6.2%, depending on where you're located. So in an arid environment, it might be higher, but they also say that they studied it and found that you need to have 20 millimeters of rain in order to thoroughly clean a panel. So, you know, rain will typically clean the panel, but 20 millimeters of rain is going to be required to really clean it. If you just get a drizzle, it may just move the dirt around a little bit. So
in our area, we have a soiling that's very special. It's white and it comes in winter.
oh yeah,
The
well,
soils, is that part of that?
it's not listed in here as the derate, but you could add some in if you think that these panels are going to be covered in snow for a significant period of time. And there you're going to have to throw in some experience for your location. A ground mounted system like mine, I tend to clean the snow off of it with a squeegee, but if it were up on the roof, I would let it melt off on its own. And some of that's also going to be based on the angle of the array, because the sharper the angle, the more quickly that snow is going to slough off. You know, a flat array is going to hold the snow a lot longer. So I don't have a good number for you. I haven't looked at that.
I've been using 1%.
1%, that makes sense. And then system downtime, well, that's another number that I guess it could be almost anything. You know, how bad do you think your installation is going to be? You know, basically they're saying if it's broken down, it's not generating. So you should assume that at some point in time, something's not going to be working well. Although I'll tell you, with my solar array, you know, since 2014, I did have one period of about a month where we had it down, but that was because we were going to be replacing the box. And so I had turned it off, waiting on the electrician. So I don't know. In Bob's case, I would factor it in, but in most cases I would ignore it. And I'd only factor it in because you're dealing with money, you know, that you could get fined. You know, if you're dealing with customers and it's just a matter of setting expectations, putting that in may cause more problems than it solves, because you're basically telling your customer this system isn't going to operate for a period of time. And that may not be news they want to hear when you're first doing the system. So in this case, you multiply all these things together and you get a system-wide derate factor. And so what is the appropriate derate factor? I don't know. In a completely unshaded system where everything is handled by module level electronics, you may find that you've got 3.5% here, maybe say 2% if it's a windy or wet area. So 5.5%. That might be all. Or well, there's inverters. So there's going to be 2 or 3. I think microinverters end phase are what, 98% efficient or something like that. So you're really only talking 6, 7, 8% derate on a microinverter system without shading. That's what I would anticipate anyway.
So was that 77% derated? I mean, 33% derated?
That one, well, what was being shown there was if you added everything together that they're giving as an example, then yeah, it's got a 37% or so derate. It's only going to be operating at 72% efficiency. But again, if you've got module level power electronics, you don't need this one and you don't need that one. And you don't, or no, you need this, the inverter. You don't need the module mismatch. With microinverters, there's no DC wiring. So you might get rid of that. And you might get rid of your downtime and you might reduce your soiling and if there's no shading. So I guess the point to take away there is that all these different derated values need to be taken into account, but they don't all apply in every situation. Okay, depending on the equipment you're using and the site that you're installing at.
Well, we came up with approximately 10%. It was really more towards 8%.
Yeah.
For my situation.
Yeah,
the
plus your
15%.
15 for shading. So we said derate it by 25%. But I would have been less aggressive than that had there not been real money involved. You know, if it was just a matter of setting customer expectations, I would have been less aggressive than that. Okay, so any questions on any of this? Okay, anything else for the good of the cause before we call it a day?
Just one thing. I remember a long time ago, I mentioned that there was a trucking company that was going to have stations where they can switch out the batteries at
Oh, yeah.
regular intervals. So they don't have to. I was reading an article about China. The car manufacturer is actually, you buy the car and lease the batteries.
Oh, yeah, makes
And
sense.
I think that's going to be the way of the future. You buy the car, and as soon as the batteries get to a certain hours or whatever, you just swap it out and they give you another one. And you just, it's part of your, it's lease plan. And I think that's very efficient because they can put a big solar array up and they can keep those batteries in good shape for you. And then when it gets too old, just swap it out. Just get another one. So I think they're going to be a leader. So it looks like China's going to be a leader in that particular area.
We shall see, although I don't want to send my car to China to have the battery swapped out. So,
So what I'm saying, if they're saying they can do it, I can't see why we couldn't do it. I mean,
yeah,
you get to a point, you go to the Ford, and like they were praising the Lightning. It'd be really good if you could just take it to the Ford dealer and they take the battery out and give you another one. And then
I know
you
there
just
was,
pay.
years ago, there was a project in Israel that had that same kind of idea. So
Yeah.
it'll be interesting to see how that all plays out. We're still in the early days on all of this. Okay. All right.
Yep.
I think we're beyond our time here, so I'll cut us off and we'll see you all next week, next Tuesday. Thanks.